everywhere is a bottleneck, in fact, or potentially could be. And again, we're going to get into a little bit of detail now about how these models are changing, and that impacts this stuff. You'll see a few numbers scattered about, taken from various research papers about the worst case scenarios in terms of the amount of time taken waiting for data. Hopefully these are worst case and they don't want to happen at the same time. But the point is, even in ingest and data preparation, that can be a bottleneck. That when you're in the superpod world and you're running large scale multi-epoch training, then you can have bottlenecks in terms of loading the data. You've got to load the models into GPU and load those checkpointed models from transfer learning back into GPUs. The training phase in green here is like the one you want to be doing. You want to be spending all your time doing that, preferably. As far as storage people are concerned, we want to take ourselves down to the minutest amount of time and leave that time for productive training. And that's really what our job is at DDN. Then finally, this checkpoint stuff, as we said, for many reasons, including managing very large-scale systems for multiple months and having very long-running jobs, we need to checkpoint those things. And then finally, we have to distribute those models. But the ratios of how important these different elements are change over time, and they change as the ecosystem is changing. So for checkpointing, for example, we've been in a world which is, large checkpoints being regularly taken. We've got a customer right now who is trying to keep the checkpoint times below a small number of % of the whole runtime. Makes sense, right? Because that's wasted time. Because when you do a checkpoint, nothing else happens with synchronous checkpointing. Now we're trying to cope with that by adapting the software so we can move the data asynchronously, so the compute can continue while the checkpoint is happening. But it takes time. These models have got to be matured. So checkpointing is one area where things are changing. Models are getting bigger, but the approaches we've got to minimize the impact whilst training are also getting more sophisticated. And that's happening across this kind of picture here. And on the ingest and data preparation side, I say many of our largest customers right now, they're building massive hyperscale infrastructures because they're trying to get a competitive edge on the rest when it comes to this next generation wave of large-scale multimodal models. And that means we're going to be ingesting much more images, video, sonar, radar, audio files, all these very large format files. Large language models were quite tough. But actually, look at the data we got to use for that. It turns out to be, a pile of words. When you deal with images, video, LiDAR, radar, audio, then all of a sudden that ingest, that data preparation, that data movement from edge to core, the left-hand side of this picture becomes much, much more important. And then the data load, of course, becomes a much more critical issue. So things are changing in various ways. Some things get better, some things are getting worse. But overall, we're sitting on top of this exponential growth across the board.